How's everyone doing? Come on, you can do better. How's everyone doing? That's what I thought you said. So my name is Bill Walsh. I run a company called Power Team International. We do live events, invest in companies. We do business workshops, speaker programs, expos, lots of masterminds all over the world. But tonight, we've launched something very special here at Ahern, and this was really at the request of Don Ahern, and he's the owner of the hotel in case you don't know, and his son Ryan, was to have a night on Mondays where it was all about tech, science, entrepreneurship, and futurists. Is that kind of cool, yes or no? How many folks, by a show of hands, are actually involved with some kind of tech or science here tonight? So we got a lot of tech folks. How many are entrepreneurs that are here tonight? So a lot of entrepreneurs, right? So we would like, if you guys enjoyed tonight, to do us a favor and invite some more folks. Every Monday night we'll have something kind of fun for you guys. And of course, we would like to hear what you would like to hear about. Does that make sense? So think about things that, hey, if we could hear about this stuff or what's going on. Tonight's about automation. Obviously, if you don't know Don's story, he'll share a bunch of it with you. But they've been involved doing business here in Vegas since 1953. They started with a gas station, which was also a truck stop, where the Stratosphere is at today, and grew that into a multi-billion-dollar company doing business in more than 7 to 9 countries, over $1 billion a year in over 70 years. But his passion, his true passion, is he's an engineer at heart. Does that make sense? He likes to fix things and build things and create things. And he's been very, very good at it. And we were just at a show last Monday called FabTech in Chicago. And it was literally like, if you could imagine seeing the future right in front of your eyes with some of these companies, you are watching the future be created right there through robots and automation and new technology, and where they put a lot of these pieces together into machines that are going to set the tone for the future. And so when Don and I talked about it, I said, you know, we should do something about automation. And this was this morning. How long ago? This morning. And he said, well, maybe we should do it like next week. I said, no, we should probably do it tonight. I said, we can send some information out. Some people are going to come out. Let's have some fun tonight. And if you haven't seen all the new activations at the hotel, I want you to write these dates down. October 13 to 15, and you guys will all get invites. We're going to throw a huge NASCAR party here. Is that okay with you guys? We're going to have a thing called Meet the Drivers. Would that be kind of fun? You'll all get to come out as our guests and meet the drivers and be a part of a really cool party. It's either going to be on the top of the 7th floor up there, or it'll be somewhere in the lobby in the main event center over there. But if you'll write down October 14th is going to be race day, and then that evening is going to be a huge party here. And tonight we're going to give away 1 ticket for the NASCAR race. Would that be okay, yes or no? Somebody here is going to get a free ticket to go watch the NASCAR weekend. Who's actually, are there any fans of NASCAR here? Let me see. Oh, so quite a few. Well, NASCAR is going to take over Vegas. November 17 to 21, we have a company doing a buyout here that's going to do a big Formula One party. And so we can get you some details on that as well. We're planning to host the Lee Steinberg Super Bowl party here. That'll be obviously February of next year. But on Tuesday nights, right back here tomorrow night, we have political night. It's hosted, if you guys know George Harris, he hosted it every Tuesday night. They always have an amazing, amazing guest that's here that you definitely don't want to miss Tuesday nights. Wednesday nights is karaoke. So how many here are singers? How many here think you are singers? It's okay, right? So you can practice and have fun and laugh, and it's a great night here, and this is a wonderful theater for this. The sound, the lights, the screens is absolutely epic. Then on Fridays and Saturdays, every Friday and Saturday, we have comedy plus karaoke. So if you've never been here for a comedy night, I'm telling you, you're missing out on great shows. How many here believe that laughter is great medicine? Let me see, hands up high, right? So how many guys could probably use a few more laughs in your life, for sure? So if you guys have a passion for this stuff, it's free to get in. You just have to buy 2 drinks. Does that make sense? So Fridays and Saturday nights, every Friday and Saturday, and Ryan Ahern and Lorenzo Clark host that night. So if you know someone that needs some more laughter, have them come out for that night. Don't let them miss some of this stuff, because I do believe that as a world we need more laughter as a whole. Would you agree, yes or no? Give that a round of applause. I think it's so important these days. And so what I thought I'd do kind of tonight would be kind of fun to kick off is that how many here once again would like to get all the updates for the hotel? All the updates going on. Who would also maybe like to win some free gifts every once in a while? Would that be okay too? And who would like to win that 1 ticket for NASCAR tonight? Put your hands up high. Let me see. So take out your phones really quick. Let's see how techy you guys are. Let's see how fast you guys are with tech. Everyone take out your phones. Only one person gets the NASCAR. Everybody gets updates on all the tech events, all the other events at the hotel. So you're going to text the word tech. What is the word? So TECH, text the word tech to this number 26786. So text the word tech to 26786, and let's see how fast you guys are with your phones and your fingers. Once again, text the word tech to 26786, and let's see who's the fastest. It's almost always someone that is doing a lot of social media. They're almost always the first one to win the contest. Well, let's see how you guys do tonight. And let me know if you guys get a message back. You got a message back already, but you'll probably whoever got the message first, we're going to send you a text tonight that says, hey, you also win the NASCAR ticket. Is that kind of cool, yes or no? And we might give away one extra NASCAR ticket at the end of that. Would that be okay too? Yeah. Yes? You guys ready to have some fun? Say hell yeah. Turn left, right. Tell someone you look good. Now do it one more time and say, but I look better. Because you got to have some fun, yes or no. So I will tell you this, that I'm very honored to bring our guest up tonight. I've had the opportunity to work with him for the last 4 months. We met a couple years ago. He thinks he learns from me. I get to learn from him every day. Does that make sense? It really is an honor when you can spend time with people that are world class. They do what they say they're going to do. They're consistent with it, and they actually care and they give back. And I will tell you that our host tonight and our guest speaker tonight is someone that he is in all of those things. And he's also a great dad. Can you leave the white lights on? That's fine. And I'll tell you this too, that if you get to spend any time with him or his son Ryan, you'll see why they've been so successful. They're consistent and they're persistent, and they make a difference. And they do it with all their employees, and it's not just the employees. One thing we've talked about is that it's not just the employees, Bill, it's the families of all those employees that he gets to make the difference in. So I want you guys to do me a favor. Could everybody stand up? I want to give a nice, amazing, incredible Las Vegas welcome. Mr. Don Ahern's in the house. Come on, guys, give it up. Little music back there. We got some music up there. Turn it up. Come on now, let's go. Thank you, thank you, thank you. Now, Dan, I need you to stand right here for a second. Stand right here just for 1 second. I want you guys all to turn around and face the wall, face the window. Now, I want you to take your phones out. Come on, Daniel, stand up. Take your phones out. You're going to make what's called a selfie. What's it called? So you're going to put yourself in the picture with us, right? And then you're going to share on social media at Ahern Hotel. There you go. Come on, let's go. So if you guys have Instagram or Facebook or LinkedIn, now you tag it right there, and you ask your friends if they'd like to get free gifts from the Ahern Hotel. All they have to do is text the word tech to 26786. So Don, with that, I'll give it over to you.
Thank you, Bill. Good job, Bill. Quite the promoter you are, my friend. Good job. Welcome, everybody. Glad that y'all came out tonight. I'm very honored that you came to see me. But I see a few friendly faces out there, and it's really nice. Really nice. You know, it's been a long journey. You know, in fact, I told my wife, says we're kind of working on our estate plan, which includes the burial plot. And says, well, what do you want to put on there, you know? You got to put some words, couple of words that mean something. And I always said, I'm going to put, you know, life's a journey. And I enjoy the journey. She says, I enjoy the destination. So if she's going to put destination, I'm going to put journey on there. But we've had a good long journey here in Las Vegas. And tonight we want to kind of stay centered in our automation. And I'm going to tell you first off, I and my team that I'm going to bring up here, we are in a learning curve. A couple of these gentlemen I'm going to bring up are mechanical engineers with degrees with kind of a specialty of automation. So they've been working in our factory down there. And I'm going to bring them up here in just a moment. But first I want to tell you that after we sold Ahern Rentals last year on December 7th last year, we pushed on or conveyed on 2,300 employees, went on to United Rentals. And it left us with just the manufacturing. So it gave me an opportunity to really focus on manufacturing. Now, we currently have half a dozen factories around the world with about 1,400 employees left right now. And we're producing about 8,000 pieces of equipment per year. scissors, scissor lifts, boom lifts, and forklifts. So with that, we kind of started this all 20-some years ago, and it was real hard for me to focus on it with Ahern Reynolds, but now I don't have Ahern Reynolds, so I'm kind of focused on the manufacturing side. And I'm telling you, I'm going to get a little bit political here for just a moment, but we have a problem in America. You know, it's not America first anymore. And we have a problem competing. I've got container loads of product coming out of China. Container, I don't know, maybe one, right now, maybe 1 or 2 a day, containers coming out. We used to have a lot more, but we shifted it all over to India and up to South Korea, not North Korea, okay? Although we do get our missiles up there, but it's a real problem, you know. And I can tell you, being a manufacturer in America is really tough because our government isn't doing anything to actually really help us as a manufacturer. You know, we don't even hardly build a ball bearing in America, you know. And what we're building, you know, kind of originates with raw steel. And Nucor Manufacturing sells most of the steel in America. And they have such control over the supply of steel that they control the cost in America. And we're producing at about $3 a pound right now. So a widget made out of flat steel and all these things that are, and I can buy that same product for about $1.80 a pound shipped here from China. So you can see the politicalness, and we can get into that a little later, but we'll stay on focus with some automation. But I can tell you, that is why we are automating. We have got to get the labor down. In China, it's $4, $5, $6, $7, $8, $9 an hour, depending on whether you're right in Shanghai, near Shanghai, or the further away you go, the hourly rate goes down. But, you know, in America, you know, we're in the 20s, you know, for everybody. And it's almost a function of 4, or a factor of 4. So I've been off on a journey to automate this steel, the steel fabrications of our products that we build, because I'm frustrated with trying to just get the cheapest cost, pushing China against India or against South Korea or Malaysia or even Mexico is really becoming a hot spot. And if anybody wants to talk about that part of it, we can talk later after we've talked about automation. But I think the way to win, since the government is going to penalize us for even trying, is to automate and eliminate the labor, because these 20 to 30, sometimes even $40 an hour to do welding and things like that, it's just almost impossible. But when we got the tariffs going into China, and we got, thank you, you put some whiskey in there? But when there was lawsuits by the manufacturers suing China for dumping and all this stuff through the Department of Commerce, and they put like 200% tariffs on this stuff. So we started moving to India, moving to these other countries, but we also went into our own fabrication, which we were always in it a little bit, but more hand-to-hand combat, you know, cut, weld, all this stuff. And now we're going into automation, because that's the only chance we got, is to eliminate the labor. A pound of steel costs me between 50 and 70 cents a pound right now. That's kind of the going rate, whether it's 50,000 PSI steel or anything a little bit tricky goes right up to 70 or up to 90. China is probably closer to 20 to 30 cents a pound. They're buying the steel. The iron ore is coming out of Australia, coming around to Taiwan, little area down there called Gushong, and China steel is actually in Taiwan, and that steel comes in. And how are you going to compete with them when they're buying the raw product? We're getting screwed by Nucor, who is just damaging it. But our goal is to try to get some sense into our government. You know, they talk about we need to be self-sufficient, but they don't do a damn thing to help you go into manufacturing. You know, now they're passing big bills for chips, but the chip, that was after the chips, you know, we have no problem with chips anymore. There's plenty of them today. Last year there was not. So with that, we're going to go into automation, and I'm hoping that automation makes me the winner of this big game that we're playing out there to bring fabrication or manufacturing back into America. So first I'd like to invite Sam Guron, if you could come up. Sam is our Vice President of Engineering. He comes to us from a great company that you guys all heard of, maybe called Caterpillar. We call it Kitty Pillar. We actually build forklifts for Caterpillar now. And so I'll give you this in a moment. And but Sam has about 35, 40 people that work for him. Most of them are engineers in our engineering department. And next, I'd like to bring up Dave Lawton, who is our Director, Vice President of Fabrication. Now, we have about, yeah. So we have about $40 million worth of fabrication and automation equipment back there that Dave is responsible for. And now that we're done with the pretty faces, I'm going to bring up a couple of smart guys, okay? Brandon Alber, who's a degreed engineer with an emphasis in robotics. Very proud of him. And of course, you know, the younger the better, right? Well, I'm scared to fall. And then we've got John. Come on up here. John Milchek. Milek, yeah. And John is an automation guy, robotic, another engineer. And so this is my team down there, and we have about 400 people working for us out here in Henderson, almost 500,000 square feet. The fabrication side of it is actually about a little over 40,000 feet, where all this we're talking about tonight occurs. And by the way, everybody's highly invited to come down and take a tour. You know, it's pretty cool. Yeah, it really is. We'd like you to come down. It's I mean, you know, you got to figure about 2 hours to get through that 500,000 square feet down there. And the assembly side, after we sometimes start with assembly because that's the pretty part. But really, very honestly, some of this equipment that we build is pretty big. We build the world's largest forklift, build the world's largest boom lift, and one of the world's largest scissor lifts. Now, our boom lifts go 210 feet high, and I think, how many here have been up on a boom lift? Is there any contractors, any of those kind of guys around here? Yeah, okay. So, anyhow, you get up 60 feet, kind of scares you. You got to get up 210 feet. And this machine will turn its wheels 90 degrees, so it goes left and right, and you can drive it from 210 feet. It's pretty amazing. I think it weighs around 92,000 pounds or so. Is that right? Yeah. So, and then we got the world's largest forklift down there, which is called Trackzilla, because it's not on wheels, it's on tracks. It goes 100 feet tall. Doesn't sound like much next to the 210, but for a forklift, they almost always operate in the 30, 40, 50-foot range. So 100 feet's quite high. And this is built particularly for the Amazon projects or projects like those. And it's pretty amazing. And they build big, our customer puts a big hand on it that picks up sections or roof sections bigger than this theater, or wall sections, or mezzanines and so forth. You'll see it if you come down. But anyhow, we're gonna dive into some automation here, okay? And we're not using AI, just so you know, not yet. We're using degreed engineers. That's what we use. But do you guys want to start with your deal? First off, would anybody here, you want to say something?
Yeah, thank you, Tom. So thank you, first of all, thank you to all of you for taking your time from your kind of busy evening to come listen to us. And as we all know, automation is the way to go in future. You look around, everything is automated, all these robots, everything, the more and more automation is coming in. So what we are trying to do, not trying, actually doing it, from the engineering side, even planning to take it one step ahead towards the fabrication and manufacturing. Just to give you kind of quick update on this, we, on the engineering side, for the extreme manufacturing and snorkel, our engineers, they design the systems, the subsystems, and selecting components. Everything is being done just in the computer, just a software design, right? So it's all done there, and these guys really put life into that. So that's where they make all these really beautiful parts in the fabrication that you can see and feel and touch. And the engineers, what the team is doing in the engineering is basically doing the soft design. So talking about the automation, the next generation plan that we have is to do all the design in 3D instead of cutting the 2D prints to give it to this team. So we're gonna move this whole 3D model to this team here so they can pull that and feed directly into the CNC machines programming and use the robots and do all the fabrication over there. So I'm not gonna steal their thunder, so let them talk about how really they do all the automation and how they fabricate all those parts that the team is doing, just a design and soft in the computers. So with that, I'm gonna turn the mic over to, you wanna say something, Dave?
Nice to have you all here. This is like 45 minutes worth of hurry up and get her done. That's what we do in fabrication. We just do what we can. That's why automation is so key to our world. We did have a little presentation that we threw together, trying to explain what we do, why we do it, and how much we have been able to automate it to cut that cost down so we can try to compete with China and India and all the other good places that can do it cheaper. But our goal here is just to do what we can to make enough money to keep growing. That's the whole point. The first one you see, this is the state-of-the-art tube laser. It will cut tube, angle iron, I-beam, all kinds of things. It'll cut it in any direction you could possibly imagine. You put the bar in it, and it spits it out the other side. So there is nothing in between, and that's what automation's all about, is try to take it from raw material to a finished product. Every time you have to touch a part, it's costing money. So what we're trying to do is automate it as much as we possibly can as we grow this and keep it going. Next, who's clicker? Hey, here we go. All right, so this is showing you our two plate lasers. This plate laser setup is two 10K lasers side by side. It has an automation to load it and to unload it. Again, a guy doesn't have to touch it except put material in and pull material out. That's part of our automation. We're also looking at some other lasers setup that'll actually start picking and placing the part off of it as it's been cut and palletize it. And then all we have to do is pick it up a forklift and take it to the next operation there might be. The less we have to touch, the better off we are, right? John, click. Questions. Any questions on that so far? I just talk quickly. I just have this habit. Okay, so this right here is just our nitrogen generator. What this thing does is pull the nitrogen out of the air because those lasers cut with nitrogen. And this is a thing we put in place so that way we don't have to buy tanks and so forth. So once this thing's hooked up and it runs, we just turn it on and it just keeps feeding the lasers nonstop. We don't have to worry about anything about changing tanks. If anybody's ever had acetylene torches and you run out, you got to change tanks and all that good stuff. Guess what? I don't have to. We just turn the power switch on, hit the button, say, let's go. And it'll run nonstop. So, and it, again, 24/7, it's not going to stop. So that's another thing we don't have to worry about. Next one. Trying to get through this. Okay. Yeah.
Just want to make a point on that nitrogen generator. It's kind of cool. Does anybody in the audience know what percentage of the air you're breathing today is oxygen? 21. Almost got you, didn't I? Yeah. That's about right, 21%, yeah. So that means the rest of it is mostly nitrogen. So nitrogen is 79. It's actually about 78, but it's right in there, right? But somewhere between oxygen and nitrogen, which represents about 99% of it, there's still some other stuff out there, right? I don't know. You probably know better than I, but what is it? 1% everything else?
It's not carbon dioxide. You don't have to get on that path.
No. But the thing is, if a lot of people think you're breathing oxygen, you're really not. You know, you're breathing mostly nitrogen, you know. And of course, we enjoy the oxygen that's in that air. But that machine that he showed you, the nitrogen generator, it just brings the air in. It compresses it to I think around a couple of 100 pounds of the first stage, and then it takes it and puts it through a separator and ends up. How many pounds of pressure is in the big?
450.
About 450
PSI,
pounds.
yeah.
So this is used only in the laser for us. So that nitrogen goes into the lasers. The laser shoots the beam, and he said that's a 10K machine. That means it's 10,000 watts. And 10,000 watts in a laser beam will go right through the steel, and it melts the steel. But it doesn't really cut the steel. It just turns it into molten, and then the nitrogen gas blows through it. Okay? And then it moves really, really quick. And the thicker the material, the slower it moves. But the real thin stuff, like, say, 10 gauge or something like that, it goes so fast you can't hardly see the head moving around in there. But a lot of times we take the nitrogen, we turn the valve over, and we pull in pure oxygen. And the pure oxygen actually is hotter, burns hotter than the nitrogen. So then we can actually, let's say we've got a machine that'll cut real comfortably with pure nitrogen up to about a ½ inch thick. But then we want to go to 1 inch thick. Then we put oxygen in there, and that makes it a hotter cut, because you're never going to cut 1 inch very well with just nitrogen alone, So continue on, Dave.
Okay. To that point, when the oxygen side, you got to cut it bigger. So when you're cutting thicker, it's got to have a wider cut, and that's why you introduce the oxygen, right? So we can cut it. You think about a piece that's this thick, and you're piercing through it quite, 8-10 seconds. The material's got to go somewhere, so that's what the oxygen does, is cuts it, blows it out, and it has to increase the width. So when you take your part out, it doesn't stick back to it. So that's the main key about the pressure and everything else when it comes to the nitrogen. What you see here is basically new machines. These machines are set up, you can see my bottom left-hand side. You see the little thing that has the M on it on the right-hand side of that picture? What that is, it's a table changer. And basically what we do is we have bices so a guy can put the parts in it, loads it, pushes the button, it shuttles that thing into the machine, it's machining, he's loading it again. And it just keeps going as the guy keeps loading, and when it's done, it comes back out, he pulls the parts out, he loads the other one, pushes the button again. How automated can you get, right? Our world is doing nothing but, in this setup, is spinning and creating chips, right? That's how we're making money, is spinning and creating chips. Hit the next one, John. Press brakes. These things right here in automation is basically moving into the world of robots. Eventually, these machines will have a robot in front of it that actually holds the plate, moves it, twists it, so it puts it back in the machine, and the machine comes down and makes the bend. It doesn't have to worry about a guy standing there and doing it. There's sheet followers that go with this. There's all kinds of other automations to go with it. Some of these are the newer ones that we have. We got a couple new ones out of it, and it's really going to get to the point of automation where we can eliminate the manpower when it comes to one of these. Next one there, John. Where are we at? Robots. This is our world right here. This is our world. This is what we started out with. The robots that you'll see in this is some of the biggest robots in this state. It'll take a 34,000-pound chassis and flip it around like it doesn't even know it's there. And the robot just comes in and does what it's doing. Basically, what this robot does is it takes about 2/3 of the manpower labor out of it. So in other words, this thing will run for 1/3 of the time with not even a man involved with it. Welds this thing up completely, we take it off, we got a finished product. These are the best things that we have down there right now that I love. These guys are just constantly working with fixtures and programming them and all that. And it's growing. We've got 7 of these things in our facility. That's why when you want to come see a tour and see something very neat. Anybody know what a 7038 is? In our world, rental world? Yeah, some do, some don't. That's all right. Hey, it's the largest telehandler on the market, right? Picks up 70,000 pounds and moves it out 38 feet. Well, this machine will take that chassis and just do whatever we want with it, right? So that's pretty amazing when you can do things like that. Next one there, sir.
Hey, Dave, you might tell them that on that previous picture, the robot is actually the little orange part on there.
Yeah.
Okay. So you see that upper left, kind of the yellow vertical line, and there's the orange thing right there. That's the robot, that orange part up there. The rest of it is a tower. It's about 15 feet high, and then it has a diving board. We call it the diving board that holds the robot. So that tower will rotate 180 degrees, and that diving board will go up and down, and then the whole tower will move 50 feet to the left and 50 feet back. And then when it goes out, it reaches out about 16 feet, so we can reach out. And he says that's the biggest in the state. Those are the biggest west of the Mississippi. Yes, sir.
Your equipment here, what country is supplying it?
The robots are made by a German company, ABB. Yeah. So, but I think these young guys could probably give us some real detailed information if you want to. You want to tell us, Brandon, kind of tell us how many axes and what's the software that you use on those?
So these are ABB robots. I don't know if they're Germany or Sweden, but you get most of your robots either out of Europe or Asia. ABB is one of the premier welding robots. They got first in the market. They're all 6-axis robots, and then they all have external axes that are configured into the controller. So anything that is manipulated through the teach pennant is an external axis that's not on the robot. So as he said, the gantry that moves back and forth, that's an external axis, up and down, turning in and out. These are all external axes that have to be coordinated with the motion of the robot. And all these robots also have seam tracking, and Dave can probably talk about that a little bit more than I could, and search capability. So there's continuity, so the robot will actually go with the wire or the tip and touch the material and sense where the material is. That way you make sure that you get the perfect spot to weld. We're still working with the human factor, so parts aren't always exactly where they need to be, and the robot is a perfect machine in a sense. So there's the search capability kind of brings that back together.
Thank you, Brandon. And these guys, they tend to kind of work two sides of this thing. Brandon's kind of more in the programming of the actual robot, but the part that what we call the positioners that hold this 35,000-pound chassis on a 70,000-pound capacity forklift, the actual chassis, the raw chassis, is 35,000 pounds, and we have to take that 35,000, we have to rotate it around. Sits on a big flat, we call it the platter, and that positioner, it takes a lot of work, and maybe John could tell us about positioners and the way they work intricately with the robot. They have to turn.
I'm a design engineer, so when Sam's team is done designing the forklift itself, if you will, they'll pass me the chassis, and then I design the tooling and the fixturing needed to apply it to the robot for Brandon to take over and do his part, program it, weld it, like you said.
I think we'll get more into some of the positioners in a few more slides, and it shows some of the capabilities of it being inverted. Top Gun fans. But yeah, if we can keep going. Oh, you got a mic.
There's one.
Yeah, so this is actually a 3034 chassis. This is the newest project that I've been working on. This is our newest robotic system. This is going to handle our D, E's, and F's, some of the biggest chassis that we have. Right here you can see that the positioner is rotated at 90 degrees. I've been working with a lot of Sam's team, a lot of their professional engineers, to make sure that we get the loading correct and the bolts and the strength to make sure that when this chassis is completely upside down that it's secure, and making sure the center of gravity is in the position that the positioner can actually handle it. So can everybody tell what the chassis is in this picture? It's on an I-beam, and that's what the tooling is actually. So that's what me and John worked to build, is the tooling that goes on these robots. So the chassis is that the lighter gray or the darker gray?
I want to point out a couple of things here. So this orange thing here is the robot. This is the diving board. That's whatever. What do you call that part? Tower. Okay. And that tower runs up and down this 50-foot long, like a train track. And this whole thing rotates around, and that's actually the chassis right there. So what John creates is this part, which looks a little simple here, but it's usually they're more complex than that. But this whole, all the parts and pieces to make that, it kind of come together in a fixture, get tacked together, and then it gets mounted up onto this part, which is not necessarily part of the robot. That is unique to this chassis. So we can actually do a different chassis or a different, totally different kind of thing by changing this part. And this part stays constant at all times. And right in the, does this one have a platter in this picture? Is there a platter on here? Yeah. So there's a platter. There you go. All right. So now
So you can kind of see the platter there. It's the dark gray spot right there under the chassis and the I-beam. And this is in the inverted position. So with the external axes, with the reach of the robot, that you have to have these configurations. We only weld in a horizontal configuration. So any way that we can manipulate the chassis to get that configuration to weld. The platter also rotates 360 degrees. With a 35,000-pound chassis, it rotates slowly, but it will go 360 degrees or 180 degrees and go back to whatever configuration we need to work on both sides of the chassis. These are currently being welded out by hand, but how much time do you think we'll cut off with the robot with these guys? 2/3 of the time?
2/3.
And consistency is much greater. You can actually do a lot of welding that is not certified by hand with robots. So around slew rings, stuff like that, you can get more consistent welds. That you can get a weld that runs for 2 or 3 hours at a time, where a person can't weld continuously for that long, understandably. So this is the actual picture of that station. You can see the platter there. We just got the fixture back from paint and still working on programming it. And you can see that the tower is more moved towards the center of the station with the robot. You have to calibrate the tooling to the robot, so you touch off a few points to create a work object, and that follows on your program. So if anything ever moves, you can reset the work object. Yeah, so this is just a load chart. You can see the center of axes for the platter and the drop center. These are critical. So the top sections of the drop center are counterweights. With this total mass of the I-beam and the chassis, this is the 7038, the biggest chassis. The center of gravity, this one can hold 50,000 pounds.
110,000 pounds.
Yeah. So, but it's inside of an envelope, so we had to make sure we get this center of gravity in the position that the motors can actually handle, and that's again where me and John have to spend our time to make sure this thing is going to work the way that we intend it to. I'll let you take it from here, Dave.
Okay, this is just another picture of a fixture sitting inside of the robot. That's the different orange in the middle. That's basically all it is. We're trying to show you what we have. We have multiples of these. We got 7 of them. They all different weights and different kind of configurations to do what we do. Let's hit the next one. All right, this is a nice one. This is a smaller robot. What this is good for is it actually does more rotating in other directions. So in other words, a guy could be on this side, it can get loaded, and it's welding on the opposite side. So when it's done, it rotates back. You can load it and keep it going. So it just keeps going back and forth, back and forth. Again, it's always welding in automation, and we just get to keep it loaded and unloaded, and that's all this thing has to do. And the thing about robots is sparking, right? Creating a spark, creating a weld. It's how you make the money, and that's what this thing is really good at. It's only 5,000 pounds, but it will produce a lot of parts because it goes nonstop. Okay, let's go to the next one. Where are we at? Bigger picture. So now you really get to see what a robot is. The white thing is actually the robot. The other things are just the positioners and controllers for it to move. And what he does is he programs that arm to move to wherever it's got to go to create the weld. And he does his. And I think, do you have a thing on a robot studio that you showed earlier? Basically, what we do is we don't program this out on the floor. We program it in the computer. So while we're building fixtures or you're running other product, he's already programming the next one to go on it. And then we just load it into the robot, and it'll come up and start. Okay, so this is basically a robot studio. What this does is it helps us double up on time, is basically what it does. He's able to program the whole thing. We put it out on the floor. They can put the chassis on it and run, right? There's no downtime. There's no time out there having to do manual stuff. And that also concurrently does it if you're building a fixture, right? They could be building this fixture. He could still be inside programming it, right? So we're trying to cut the time down. Let's go back to where we were. Go to the next one. That's just another fixture as the thing goes. What else we got? Is that the last one, John?
I think we got one more.
Okay, this is a machine that is a horizontal mill. Basically what this does is what we do is we call them dumb parts. That would be me. And we try to make them smart. That would be them. So we have the welding fab guys that tack it together. We put it in a machine. We weld it off on the robots. Then it goes in here. It does all the machining, all the surfaces, all the bores and so forth. So what we're trying to get at is what we're doing is we're taking the metal, and it's going to move when you weld it, right? It's going to twist and go. And it goes on this machine, and it makes a good, perfect part out of it. All the bores will always line up and so forth. So it takes that extra position out of it, a guy having to machine it, weld it together, do whatever you got to do to fix it to make it work to the print. Is that the last one?
I think so. look at that.
Oh, we got one more.
Oh, that's the tube bender.
This is a very good piece of equipment. This thing will bend all CNC. It will take 4-inch in diameter or 3.5 by 3.5 quarter-inch wall tubing and bend it in any combination you want. You put the program in it, right? So they put the program in it, and it just spits the part out. This is a pretty good piece of equipment. So it really does a great job when you're trying to do repetition over and over and over. And once you put the program in, you put the pipe or the tube in it, and it just will repeat itself over and over and over. So you're not trying to know, the old schools, you'd have to put it, manually bend this thing and all that. This is a CNC, and it does it automatically for you.
And it kind of ties in with the tube laser.
Yes,
So
go
the
ahead.
first picture we had was the tube laser. So we'll put a tube in the laser. It'll cut in any hole pattern or any reliefs or anything like that. Then it goes straight from the tube laser to this bender that will bend it in any shape, needed. So like the railing for an RT, the baskets. Yeah, there you go.
And the beauty of this is if you look at that bend, it takes the welding away. You don't need to do any welding. It's going to do
Yes.
its job.
Yes.
So that's a plus point of
And then
doing
we
the
can-
bending.
And we can make a program that just the guy, all he has to do is press a button. He can put the tube in there, press a button. He doesn't have to worry about it.
I just want to say that tubing bender is a very dangerous tool. And if you get anywhere next to you, it'll make a pretzel out of you. And it'll kill you, actually. It moves so fast. I mean, you can kind of think of like an exhaust pipe under your car, That's the kind of machine that would make that kind of deal. But we don't make exhaust pipes, but we make a lot of stuff that uses that tubing bender. And how much, Dave, did you spend? How much does that tubing bender cost?
Oh, good question. It was about 1.2 million. Oh, here we go. I speak loud, so, I think everybody can hear me. It's about a $1.2 million machine. So it is a...
John, can you go back to the FIMCO machine? That's a FIMCO, that's made in Japan, and we use that for what we call post-machining. So after the weldment's all made and it's been brought together, then it goes into this machine and gets a lot of different holes and gets a lot of threaded holes, but they're all geometrically relative to one to the other to where they're absolutely perfect. That's also just under $1 million, that one machine there. And what we didn't show you, we didn't get you any pictures of, the very first picture was a lathe, a CNC lathe. Is that right? Yeah, that machine there. And that machine now, that looks like it just arrived in this, that's the best part of a year ago, but it's up and running now. And next to that is another 5 or 6 machines, look just like it, but they're bigger. And they're called mills. This is called a lathe, and they're all called CNC, computer control, right? So they all run on numeric, and they're all very programmable. And so is there anybody in the audience that can tell me the difference between, I'm looking at the smart guy here. So what's the difference between a lathe and a mill? Okay. I thought maybe you had, yeah, okay. No?
Getting close.
Okay, the difference between a lathe and a mill. Amen. You got it. Right on. Good job there. All right. You
You're
just
hired.
won a Bentley. Okay. Anybody got any questions about some of the stuff they saw today? There's really, I really wish you guys could come out. There's
Yeah.
so much to be seen. You gotta, oh, okay, we take this one over here.
I appreciate all that you guys are doing, and I look forward to sharing some things that we can help with your robots, because we're doing a 3D printed house with non-toxic commercial waste using a robot to do it. And the snafu I get is that people in the middle class say, but you're going to take our jobs away because you're going to automate it. So as an entrepreneur in 4 generations of being here in Nevada, I problem solve and I try to think of the unintentional consequences. So what we figured out that if we did something that basically did a feasibility study of kind of like using the Native American rule where you look 7 generations ahead and 7 generations behind on how it's going to affect the community. And you showed the ability of people doing 4 hours maybe a day opposed to the 8 hour, and then cost sharing with these robots, but at the same time lowering our cost of living or keeping us competitive. We can then embrace the robotic next step. At the same time, everybody is included in inputting into our feasibility studies what works and doesn't work, and if you don't, that could just basically help if you come up with a snafu of taking people's jobs away, we have a solution for that as well.
Well, let's say first off, these jobs that we've got out there are kind of not real jobs, because we're actually in a business of doing a laboratory experiment to figure out how we can compete with China and so forth. So if we don't have these robots, there are no jobs. Point 1. Point 2, for every robot we got, we'll replace 3 people in a welding atmosphere anyhow. But the advantage is that the one job that does stay becomes a much higher paid job, because it's somebody that can run the robot, you know. So you kind of get rid of 3 people. And we say that because it kind of sounds good to hear from one point of view. But from another point of view, we're taking, in America, we're taking maybe a $19, $21 an hour job, taking away 3 of them and giving one person who is a programmer, you know, making more like $35, $40 an hour. A more sustainable job where you can own a home in this day and age and so forth. So we're bordering on politics, aren't we? Yeah.
Actually, I come from, my first job was working in automation and doing custom robotics. And my former employer, he had a good example, and he actually had a white paper on it, talking about the Industrial Revolution, where you went from most of the what's the word I'm looking for? Population working in factories, working in agriculture, all that. You went from 98% of it being agriculture to 2% being in agriculture. And everybody feared the Industrial Revolution for kind of the same reasons that we are looking at robotics and automation now. And maybe I don't have an answer, nobody knows the answer, but kind of the human persistence will go on is kind of the answer, and the bright light. But
We had another question right here.
Okay.
There's a microphone behind you. There you go.
Believe it or not, I'm highly interested in macroeconomics, and I do, frankly, anticipate a political change in the near future. But, you know, when you throw out those numbers, comparative advantage, you know, when you've got steel coming out of China and Nucor controlling prices here, it's just unfair. It's not a constitutional republic. It's not working. That's why things have to work politically for businesses to work. So I kind of think you're with the program, but do you anticipate maybe some return to tariffs and economic sanity that we had 2 years ago from this complete insanity that we have going on now politically?
Wow, that's a big question right there. Okay, a little bit political, that's okay. You need to come back tomorrow night for political night. Okay, no, that's fine. This is right in the core of my heart. You know, I am borderline angry, you know. I like to make this America great again, you know. And nobody's doing it. What China is doing, and a few other countries, you know, they're just raping America of its jobs, you know, to the point. And then we're allowing Nucor and the steel guys to, you know, they just, you know, even Trump gave Nucor and a few of those people some real advantages, you know, to get into production. But now they got the control of the market, and they just shut plants off. So when steel demand for raw steel goes down, they just shut off a factory. They just shut it down. And if you go, I've got a great opportunity to tour many of these Nucor steel plants, and they're so automated that they don't even have very many employees. So when they shut off a plant, a giant plant, you know, there's less than 50 people that don't have any work. There's so few people working these giant things that they don't even have to lay them off. They can afford to just pay them to sit there and do nothing because they're just driving the cost of steel up somewhere else. So they're just controlling supply. See, we need more manufacturing of steel. And what does steel come from? Anybody know where does steel come from? Huh? There you go. There's my chemist over here. Okay, so we get it comes out of iron. Iron is an element that comes out of the earth, and there's a lot of it. In fact, right up north of here in Cedar City, Cedar City sits in a county called Ahern County, and you can find iron ore just laying on the ground. And right now, a gentleman I know up there that's running that iron ore mine is shipping over 1,000 train cars a day of processed iron ore coming out of Cedar City area, going straight to Long Beach, going into a ship and going straight to China. And then he brings those empty cars back. 1,000 of those train cars are circulating all the way down there.
I see them going through Utah.
Yeah, you see them there. So the problem with the iron ore, when they bring it out there, you know, they grind it up into a sand and water, and they run it off across magnets to make it real quick. And they bring the iron ore out, and all the rest goes away. But it's really not iron ore. What's attached to that iron at that point? Do you know?
There's a lot of sand, and depends
What-
where they extracted it from.
Yeah.
Sand, limestone, glass.
Okay, but all that stuff is not magnetic, and so when it goes across the magnets in a like a river water, then the magnets pull the iron ore off. But attached to this iron ore is an oxygen atom. So now you have iron oxide, see? And the problem with getting iron ore into steel is like a cake, like a baker makes a cake. They make a cake out of flour, okay? So iron is like flour. You can put all kinds of nickel and copper and zinc and all these other things into the iron ore. And that combination of things makes a type of steel. It's like taking flour and making a type of a cake, see? But the problem is in America, they shut down all the steel mills. And what was center stage in America was a big diameter tower went up in the air 100 feet, 300 feet. You've seen it with the black smoke going out the top. And they've shut that all down because that was the tool. That big tower was the tool that would take the oxygen atom off of the iron atom so that you could have pure iron. You can mix it with other elements like copper, zinc, and whatever, and make steel. But we cannot make steel in America. We cannot make steel from iron ore. Okay? But I just said, Nucor makes all the steel in America, right? So did I not contradict myself? Okay. Well, here's what happens. Where do you think Nucor is getting their steel from today? What are they making it out of? Do you think they're making it out of iron ore? No, they cannot. Where do you think they get their steel from? Scrap. You got it. So the Mississippi River, some of those rivers, they have these plants and they throw out like a net, goes out for hundreds of miles on either side of these big rivers. And this, we put steel and we sell our steel here to a scrap guy. The scrap guy sells it to another guy. And, eventually it goes into these barges that come down. And then out of the barges comes the scrap into piles, goes into the Nucor plant, and they melt it down through an induction furnace normally. And it's kind of an anode and a cathode and like an arc furnace. These tubs of steel are about the size of this round area up here and 20 feet deep. And the scrap steel gets shredded up and thrown in there, and then these two big probes come down and they arc across and they melt down that scrap, and then they turn it back into an I-beam, or they can turn any form of scrap ends up to make steel. Now they'll adjust that, and they're so automated. We're here to talk about automation. Those big, everything is just a guy sitting in a control tower running little knobs and stuff. And he's putting in the scrap, and they know what kind of scrap to put in to try to end up with a close product. But when they get done, they gotta figure out, what is that scrap? What did they end up with? Is it perfectly, maybe they call an ASTM 50, 572, for some of you steel guys out here. Maybe it needs a little more copper, maybe it needs a little more aluminum, maybe it needs a little more something else. Has anybody ever been to one of these big, you've seen them on TV, right? They're amazing. To get there is amazing. You can stand right next to it, and it's like you're on the surface of the sun. I mean, this shit is just popping and blowing, and if you're anywhere close, it'll get you and burn you.
So if we had a free society here in the United States, which I anticipate we might in the future, what's the cost between like the scrap process you described and taking it out of the ground, the iron ore? What's the different cost?
Well, the cost of getting out of the ground is quite expensive, but the cost of getting that oxygen atom off of the iron oxide is something we can't do. We just cannot do it because of our environmental laws. They just won't let it happen. Scrap steel, on a per pound basis, I've seen scrap down to several cents a pound of value, and I've seen it up 25, 29 cents a pound for scrap. When the price of steel goes up, it drags the price of scrap up with it, or vice versa. It's just kind of a yin and a yang. But getting back to that one point I wanted to make, which I thought was kind of cool. When you're making a cake with flour and you're whipping it all up there, and I say, I'm going to put some baking soda in this cake, and I pour it in the top and I whip it in there, right? Well, in this case, they can't do it that way. If they put that baking soda, or let's just say it's copper or some other element, they put it in there, that heat will just explode it and it'll vaporize right on out of there. So they actually have ports down in the bottom where they actually inject that material into the bottom of this hot molten scrap. And then it mixes up in there, and then they end up with the very, very correct recipe, which is like an American standard. They got a lot of standards. We use AMST 572. Okay, that's a 50,000 PSI steel. And you can imagine if you're building a high-rise a high-rise tower building out of I-beams, that steel has to be, you can't have a stick of I-beam halfway through it. That is not correct. The whole building, that could collapse, push the torsional forces onto the one next to it, and pretty soon it come down like a domino. So steel is very critical. Nucor does do a great job of producing a very consistent in-spec product. Now, if you're bringing it out of Mexico, which you really can't, by the way, Mexico has a law, I think it's 20%. They only allow 20% of the product, the iron, steel they produce. Only 20% of it can come up unprocessed for a guy like me to get my hands on it. So let's assume I could get it cheaper in Mexico. I can't get it because companies like Caterpillar for decades have had a complete grab on that 20%. The only way I can get to use steel out of Mexico is to buy it already processed. In other words, already cut, machine, welded, bent, something. And then I can buy it up there. So they're creating jobs and labor down in Mexico. Again, not necessarily America first. Okay, great.
So comparatively, what is the Asian steel in comparison to American standard?
What is the Asian steel quality? Okay, all right. That answer to that question is different today than it was 20 years ago. The Asian quality now is absolutely on a par level with America. You can really depend on it. Now, some of the specialty steels, China really doesn't make, like Sweden is really advanced in their steel. There's a type of steel that is called Domex, that we use a lot of Domex, and it comes from Sweden. So, like I said, the steel that Caterpillar actually set the 572 standard decades ago, and that was a 50,000 PSI steel. So you can have all this A572 and you can have all these other numbers, but really at the end of the day, it's easier to just talk about the PSI on it. So if you're building a little cheap set of furniture for your patio, that's likely to be what we call A36 or 36,000 PSI. And we use 50 as a standard, but 80 is some that we use quite a bit. But if you go into some of the better qualities of trickier steel, you get clear up to 160 PSI, 160. So now, no matter what the quality of the steel is, good or bad, a cubic inch of it always weighs about the same. So when we're building a machine that goes 210 feet up there, and we might have a piece of steel up there that is 10 gauge thick, it might be 2.5 times stronger than, or 3 times stronger than A36. But we gotta use a higher quality steel to get the weight down, so we can have the same strength up there to carry the same weight, but it's lighter up there. Now, when we get down to the bottom, we want to go to a cheaper steel because we're looking for counterweight. It's like a punching bag, keep these things from falling over. You want to put it heavy in the bottom. So a cheaper quality of steel down there, we're actually not using it for structural strength, we're using it for counterweight. And we do a lot of counterweight, hang on to counterweight down there. And counterweight is typically made out of what we call cast iron. And cast iron is basically iron ore melted down. But if you take iron ore and it's still got that oxygen atom on it and you melt it down, the oxygen will gas off. It'd be like popcorn, you know, and you just can't even pour it into a counterweight. So
have an on-site person you handle, or do you have somebody on retainer? And do you go as far as to trademark the color orange that you use on your lists? And just a little insight on how you manage all your intellectual property worldwide to 7 countries. Thank you.
Yeah, I think there was a lawyer here a minute ago that, I think he left. Did he go somewhere? He did, he left early.
Yeah, he
Okay.
left probably.
Okay, well, anyhow, he's a patent attorney, and we've got about 7 patents right now in the company. And then we have a lot of trademark stuff, and we have an in-house legal department that does a lot of that trademark work. And then if it gets a little tricky, then we go outside to an outside counsel and do that. But most of our patents, we've actually used outside patent attorneys to make the patent application. The patents, we usually think of them as a protection, but quite often they're not a protection. They're a communication method to give your adversary or your competitor a clue as to what you're doing. So you have to kind of, as a businessman, you have to decide whether you want to really patent it or not, because in the world we live in, it's not like biochemistry and some of those real smarty pants stuff. You know, we'd almost rather not patent it and kind of keep our stuff thinking to ourselves. Excuse me, keep it to ourselves. You know. I don't know. Did I answer your question?
May I add a comment to that? So that's one part of the intellectual property when it comes to the invention or to get the patents. But at the same time, we are very careful what to disclose to the third parties or even with some suppliers. So we do have NDAs, non-disclosure agreement, one way or two way. So we put that in place before we share any of the confidential information with the third party. So like Don mentioned, we do have in-house team of our legals, and also if we need help from outside, then we do have a consulting company outside that we contact them.
Any more questions? Okay, great.
Hey everyone, thank you so much for hosting this. This is super awesome. I thought when I saw automations that it was going to be more digital, so this is a lot of lessons. My brother is studying a PhD in engineering at UNLV, so I know I took a bunch of photos to share with him. I have 2 questions. The first question is, you had mentioned a tour. I'd love to take y'all up on that, especially if it's an opportunity where I could bring my brother and possibly record some content. That's what we do for social media. And then my second question is, I think I'm going to try to understand the big picture, and then y'all can correct me. In order to bring domestic manufacturing up, we're going to pivot to using robots to boost domestic manufacturing. And so you have some robots that you've designed for your specific set of products. Is there a strategy to bring robots to manufacturing domestically to disrupt other industries such as steel, or even get into the business of creating these robots for other manufacturers? And if so, I mean, what do you think is the timetable for really getting adoption in robotics for domestic manufacturing?
Okay, so let me make a comment as to the labor that robots tend to replace. Most of our cost actually is not in labor. It's a measurable part of it, and that's the part that we can do something about. The cost of the steel is a secondary problem, and we can't control that. It's really a supply and demand, and I'll just use Nucor. There are a few others, but basically everybody just follows Nucor, and as long as they control the supply of steel, the price is going to be higher. 10 years ago when I was in this, deep into it, we used to have big fluctuations in our steel prices. and there was a lot of different steel manufacturers, and they would compete with each other. But now Nucor has taken over, and they've just got a monopoly. And I just don't think anything's going to really correct itself. We just can't play on the supply side. We have to just look at our labor and so forth. The other side of the coin from why would you use robots, we actually get a higher quality product by using robots. One thing we're always looking for is consistency, repeatability in these fabrications or widgets, if you call it. And the robots give us the quality. We cannot get that in the human element. A guy, and by the way, there's a lot of gals welding for us out there. I think Dave's got about 60 employees out there. And, but, I don't know what the right number is, but I think they only weld about 20 or 30 inches, before they stop. Even though nowadays we're not using stick weld, we're using wire feed. They could go forever, but I think one comment earlier was we could weld for an hour or two, with a robot. So help me out again with the question. I want to.
Two questions. One was about the tour, and the second one was I agree with the case about robotics, 100%. It's going to work. So I guess, do you think that because you're applying this in this use case, that there's going to be future opportunities where you can apply robotics to manufacture other items? Do you think you're going to be able to, help bring adoption of robotics in domestic manufacturing across the board? Is I guess what I'm asking about.
Okay. So I was at one of our suppliers out in the Chicago area, South Chicago, the other day. And they were making basically a hand and an arm. But like our arm turns at the elbow like this, they had one that telescoped hand. And we thought it was kind of interesting that they were building this one part. But they are selling that part to robot manufacturing. And they said that like the average house in America now has 2 cars, that in 10 years there'll be 2 robots in every house in America within 10 years. That's pretty cool. Now, robots have been largely used in welding, kind of in the early stages of robots. I think it was one of the applications. Now they're being used like in many, many applications. But the more people like these young guys here that are exposed to it, and the younger generation, the robots are going to really take over. Now, they're making girl robots and boy robots now. If anybody has any question about those, I can answer that question.
I got some things to help you out. Okay, so you've seen here large robots that hold large equipment. In the world we're starting to get into, we have a man next to a robot, right? It's called a cobot. Basically, this robot is capable of operating next to a man because it's not going to go 4,500 inches a minute and slap the guy over. It basically will touch him and stop. So what it is, we set up 2 tables on each side, and the robot's in the middle. He puts his widgets over here. While this little robot goes over here and does it, he's loading the other side. So we're not going to really always take man out of the picture, right? So that's some of the things, that political things, is why steel is the way it is before it used to be furnace fired. Now it's electric. They can shut it off anytime. Before, that furnace would have to always run, and they kept feeding it. Price would drive down because they got to keep feeding it. They shut it off. It takes them 4 or 5 days to fire the thing back up. Now it's each individual pot is just electrocuted and melts it. So robots are going to be in our world, AI and all this new stuff, and these, like he just said, those little male and female robots. We're trying to introduce it into our world, that we have a cobot next to a man, because a robot can't see. It only does what you tell it to at this point in time. There is scene tracking we have, there's laser tracking, there's a lot of stuff, but it's not at the advancement level that we need. Right now, we need a man with his eyes to help. Like he's saying, we're trying to get consistency in welding. we need a certain amount of penetration in it, and robots will give us 10% more penetration than a man will. That's a given. So when you've got a guy 210 feet in the air, there's a lot of things that you got to trust to do that. And that's why a robot is more efficient, more better, and it controls the well digitally, right? Not a man with his eyes and so forth. So those are the things that robots will be able to do to help improve the process. So there'll always be something involved with it. Nobody's ever going to have a plant unless you're GM or whatever that can run and build cars lights out. Even GM, as big as they are, they still have man's help in that line and with the robot. So there's always going to be a partnership between the two of them.
I got a quick question for you. I understand that it's only obvious that if you got a robot or if you got a person handling 5 robots and getting the doing 5 times the manpower as one person, you can be very competitive. But regarding the steel industry, apart from the environmental factor, where you're producing all these toxic fumes, if we could eliminate that cost, do you think here in the U.S. we could build a steel plant that could compete with China?
Oh, yeah.
I don't think we can.
Okay.
I don't think so. I don't think we can. China's got too many people. You know, there are about 300 million of them over there, and we're about 350 million, you know. United States only represents 4 or 5% of the global population. You know, it's kind of amazing how much power United States has or effect on the rest of the world when we only represent 1 out of every 20 people, right? 5%. Our politics are so bad that, and our congressional people and our senators and all the politicians, they just won't let what's right happen. There's special interest people, whether it be people from outside the country trying to shut down, you know, every time we get going. And, you know, to get real political for a minute, and unless we get a Donald Trump kind of a thinking person back in there, and I'm not saying it has to be him, but, you know, we got to get somebody that's going to think that way where America comes first. But these congressional people now are selling us out. The senators and the Congress, they're just selling us out at every turn. You know, they're creating monopolies across America so we can't compete. I think it's going to be a real problem. I'm hoping that I live long enough to see a little bit of a shift where maybe, you know, we're so far gone right now. A friend of mine has 4 sons, and these guys, this whole family is just really, really smart and super, super rich with billions and billions of dollars. I came up sharpening lawnmower blades when I was about college, you know what I mean? There's a different group. But these 4 kids, 2 of them told me over the weekend that this country is done. This country will never recover. Cannot recover. We're too far. And the other 2 brothers said that they think we still got a chance. So I don't know where you all lay on that deal, but I thought these are probably 4 of the most, I don't know, smart guys, you know, that I've been around, and they actually think that our world has gone so far. But I'm sitting here running a factory down here in Henderson, and I got OSHA coming in, driving me nuts. I got the Department of Labor coming in, driving me nuts. I got the dust bitch coming in, you know, saying I got to keep my street swept because when the truck drives around, it makes a poof of dirt in the air, you know. Government has got their foot on, let's say, my neck, but basically on manufacturing. It is so impossible that there's no way we can compete. And you get into these other countries, even like France. France makes the same products we make, a company over there, but their government subsidizes their products, you know. So now I don't know, man. I can't figure it out, to tell you the truth.
I just want to make one quick comment. You said something, I have to say this. I went to and I don't want to be too political, but I got to say this. I went to one Democratic event, and I heard one of our legislators say, you know what, we can't tax ourselves out of this problem. So you do the math.
Yeah. You can't tax yourself out of it? Yeah. Yeah. I know it. I mean, we got, what do we got, 30-some trillion dollars in debt now?
Yeah.
33 trillion. And they're paying, I mean, treasuries now are yielding over 5%. That means our government 3 years ago was paying 25 basis points on a treasury note. You know, government was paying a quarter or less of 1%. And today they're paying 5.5% for treasuries, you know, give or take. But they're all, depending on how long you go out, short-term treasuries right now are around 5.5. That means on that $30 trillion, we're paying 5%. So the cost of the interest on our debt, it's kind of hard, you know. I mean, it's like 25 or 50 times higher than it was only 5 years ago, you know. Any more questions? I love getting political, just so you know. I like making people get pissed.
Can you wait for a second, please?
Can you wait?
Yeah.
Here she comes.
I feel like we've dumbed down the population not to understand that technology is going to move us forward. And so if everybody thinks they're going to have the same jobs that they had before, they're not going to be there. So what do we do with the generations that are coming up in order to have, we are the consumers of the world, which is a problem if we can't keep some kind of a standard of living. So that's economics, that's not politics. My other question is, so I have 4 patents and 4 patents pending. And I did that not because I felt like it was protection, because I don't have the money to fight who would come behind me. I make pillows. But in order so someone else can't come to me and say, you can't make your own product that I designed. So I just wanted to, that's a double question, back to the patenting and then on economics.
I don't know. You know, maybe one of these young guys should take a shot.
I'm
How old are you, John?
a young guy.
You're not young?
41.
Well, you old fart. You know, old guy.
Hey. All right, here we go. The youngest one of us all.
What are we going to do, Brandon, about these young,
it's
what's young
hopeless.
people got to
We're
look forward to?
hopeless. No, so kind of back to answering his question as well, is educating people on what automation brings to the table. We're presenting welding here, and welding is just one aspect of it, and it's actually one of the smaller markets. Material handling, repetitious jobs, consistent things, they're jobs that people don't want to be doing anyways. They're jobs that hurt your back, hurt your fingers, things that people shouldn't have to do anymore, really. So it's educating the younger population to want to get into STEM and getting into science, technology, and all that. But that's the best answer I could give you.
I think we should do that at age 3.
Yeah. So it's gotten a lot better. I mean, the accessibility of Arduinos, things like that. Kids, you know, we did get a little bit of buffer, our age group. I was kind of scared when I was in high school and went and volunteered at an elementary school, and these kids had Lego NXTs, and I went to college the next year, and I'm playing with Lego NXTs. And so these third graders are doing the same thing that I'm doing as a freshman in college. And 2020 kind of threw a wrench in that, and I think kids are kind of getting back into being social, and engineers were awkward to be around. We don't work well with other people outside of our field, but yeah, it's kind of gotten a little worse, but we'll hope that that comes back around. But really, I think there's a young generation that understands computers, understands little things. I mean, as much fun as Legos are, but
I think, you know, God just seems to always produce a generation that's fit for the future, you know. And I sure missed it all. I can't, I mean, this damn thing drives me up a wall.
I have a really bad saying for automation, but it's laziness actually promotes automation. It's people that don't want to do stuff. And we do have a lazy generation coming up. We'll own it, but laziness does find a way sometimes, and it's not the right way to think about it, but it works.
Okay, we got some more questions.
Tech
out here.
schools. We need tech schools to teach people how to operate robots, right? How to do this, how to do that. Going to college, you know, degrees are great, but you know, it's the guy that's out there that's only making that smaller amount of wages that need the tech schools to teach them to be an operator. I struggle with getting operators, right? They're either they have no skill or they got more skills than you can deal with, and they're like him. He's a great kid. He's very smart, right? But like he was saying, it's the tech school that's going to teach these kids to get to where they got to go. Somebody's going to still have to run a robot, right? Somebody's still going. Who's going to build the cars? Pretty soon, we're going to make robots take over, and we won't be around, right? That's what's going to happen if we don't help our children become something better than what they are. And I think that's what's happened to our society. So that's my, where's that fine gentleman out there? We'll let you have it.
Hi, Paul Asher, Blackwell Capital Management. First and foremost, thank you for perfectly lining me up with that. It was a perfect setup, but I mean, among other things about the previous point, I mean, the algorithm of history is on our side. I mean, we'll obviously go through some rough times regarding, you know, systemic change, going from the old system, which clearly isn't working anymore, to implementing essentially the new system. I mean, I could get you 8,000 different subject matter experts on foreign policy and unconventional warfare and all that kind of super exciting stuff. But first and foremost, I absolutely love everything you guys are doing.
Thank you.
As you were saying, we actually are working with ATEC and UNLV to create more STEM jobs in Nevada. So I was hoping that you guys were open. I mean, it would make sense probably to, you know, put together a joint venture probably between you guys, the mining company, and UNLV and ATEC, so that, you know, you guys could become vertically integrated and you guys could get your steel at significantly lower cost, but then it would also be, you know, a place for various different participants, you know, for students to learn about artificial intelligence and robotics, because, you know, ultimately, you know, it could be really utopian or really dystopian depending which way it goes. I believe that, you know, ultimately, you know, that justice will prevail in the end. You know, my friend wrote a whole book about this called The Eternal War. You know, it's just like the responsibles and resentfuls, and, you know, the responsible people create systems, you know, like our founding fathers did, and resentfuls, you know, go through every point and corrupt every point in the system, and we kind of allow them for a period of time because, you know, evil never sleeps, and to some extent they effectively get some things done, but, you know, at the point the responsibles rise up, and I mean, every time historically we've absolutely annihilated them. So.
Okay, all right. We hear you.
Your mic died. Oh, yeah.
All right. We had one more question here. Did you want to?
I think one of the problems we have in Las Vegas, we have all this high technology coming to the trade shows, and we don't go to them.
Yeah.
We had DEF CON here, the leading source for people to meet and learn about hacking. The CIA comes and the government comes, and it's not publicized. We don't go to it. We just had a packaging convention in town with all sorts of robots, and our high school kids never even saw one building. Thank you.
Point well taken. You're right on target. Yeah, I always said that if you were 18 years old, graduating out of high school, if you just went to the convention center for 4 years straight, you'd be the smartest human on earth. You know, I think you're right there. But hey, listen, next we got some things coming up here in the future I want to tell you guys about. But the focus here in the near future is going to be energy, and we've got a guy coming that is building lithium LFP or lithium iron phosphate, solid state batteries. Now, we haven't really seen that in the past. We have literally hundreds of integrators that are taking lithium batteries out of China, which is where they're almost entirely made from, and putting them together, and we're using them in our machines, you know, all the time. There's different kinds of lithium batteries, but there's a new battery coming out. This is called Na+, or sodium plus, and that's probably going to replace the lithium battery. Now, they just announced they found all this lithium up in northern Nevada. You probably heard that. So interesting enough, if you keep coming around here, we're going to have to talk about batteries probably many, many times. But I think after you get to learn about what we're going to show you, you're going to find out that, you know, maybe lithium is not the end-all game, may not be the future. You know what I mean? But it probably is today, you know. But I got a feeling that lead acid went on forever. And, you know, Thomas Edison built a battery back in 1900 called a nickel iron battery. And then came along lead acid, and then now we're playing with lithium a lot. But in the future, we're going to see a sodium battery that's going to be 1/3. Let's just say for a minute, lead acid battery weighs this much. A lithium battery weighs that much. An Na+ battery is going to weigh even less. So that's going to open it up for drones and, you know, when you're getting some multiple of 10 or something like that of power density out of per pound, it starts opening it up. So you can see drones delivering. But we got a bunch of real good stuff coming on batteries. So, but tonight we thought we'd just share with you kind of what we're doing on automation around at kind of a root level. Everything you saw tonight is, you know, not really leading edge, but it's kind of middle America. It's kind of where we're at. We've got a bunch of automation coming that, you know, when you cut this steel into all these little pieces, now we have to grab them by hand and feed them around. Now we got a new machine coming that actually picks them up, puts them on a pallet. Our next machine's going to take them off that pallet, take it down to one of the mills or the lathes automatically, and then moves it around. So we got a lot more stuff coming. So thanks for being here, and I hope you continue to support us. And we're gonna pay money to get some real sharp people in here, like this one gentleman I'm telling you about, the solid state battery, which might be the future, at least for the next generation or next decade. So with that, thank you very much. Thanks to my team here. Thank you, guys. And stick around all you want.
What'd you guys think? Good? Come on, guys, give them some love. They deserve it. Good job. Thanks, Don. So, just so you guys know, once again, downstairs the Atomo's open tonight. So if you guys would like, there's lots of food down there, service. We're going to start having also some football on Monday nights, I think, down in the Atomo. So in case you guys want to come and watch a little football on Monday nights, one of the newest things. But also, so if you want to go down there tonight, they're open if you guys are hungry. Or you can stick around network for about a half hour. We want you guys to connect with each other, right? Have a little conversation. And of course, very important, if you guys could pick up these flyers right here from Joel's. Tomorrow night is called Tomahawk Tuesdays. How many of you guys like tomahawk steaks? Anybody here like tomahawks at all? I will tell you, this is one of the greatest steaks. It's an Australian Wagyu steak tomorrow night on Tuesday nights upstairs here in Joel's. So we only have limited reservations because it fills up pretty quick. But if you guys would like to go there, just go to Open Table, and click it on. But it's a $95 Wagyu tomahawk, which is unbelievable. And if you guys want to come and have a great party, we've also added Surf and Turf Fridays, so kind of a cool Friday for $59 for a surf and turf, and just an amazing experience while you're in there. We have Wild Wine Wednesdays, so with every 2 entrees, you get a free bottle of wine, valued about $100. So if you're a wine drinker, you will love it. And then, of course, on Thursdays, we have what's called Triple Treat, so it's King Salmon Night. So if you guys want to really have the most amazing experience, it's only been open 2 weeks, so the steakhouse is brand new. But if you really enjoy really fine dining, amazing location, definitely go check out the Joel's Chop House. Other than that, you guys can please do me a favor and make sure you take care of the bartenders, right? Make sure you take care of the wait staff. They obviously are working really hard for you guys tonight. Much appreciated. And if you guys know some great speakers that you think, wow, this person will be good for Tech Night, come and see me or shoot me a text. I'll give you guys my direct number. Just write down this number quickly or just write it down. So it's 312-543-7555. Hey, Bill, I got a great speaker for you for a Monday night. Get me a little bit of their resume, a little bit of their bio. If you can get that for me, that'd be great. But we're planning speakers all the way till Christmas now. So if you guys have anybody you think would be really exceptional to be on stage, usually it's either a Q&A or a 30-minute keynote with a lot of questions on top of that, or an interview process, something like that. But if you guys know some people like that, 312-543-7555. One more time, 312-543-7555. We'll pass it on to someone else. They'll follow up with you guys and so you might know. But we definitely have some openings. I believe at the end of the month we've got a very, very special guest. He's one of the top guys in medicine from UNLV. You don't want to miss his talk, because I'll tell you that without health you have nothing. And there's no doubt he's a futurist, but he's also at the top of his game. So when it comes to health, he's certainly way far ahead of a lot of folks out there talking about stuff they don't know, but this guy lives it every day. So if you guys could do me one more favor, give Ryan and give Don a nice round of applause. We knew tonight. We'll give them some love. Thank you. Other than that, we can turn the music back on, a little bit of music. And then also, Ryan, anything else you want to make announcements about, or Shane? If you guys have not booked your holiday parties, please make sure that you see the team about that as well. So if you know companies want to do holiday parties, see Shane. That's a president of the hotel right there. Say hi, Shane. Hey, guys. Give Shane some love. Give it up. Inside Scoop, I talked about earlier, right? Political nights. It'll be tomorrow night, same time, 5 to 7. Invite some folks. That'll be good. And, of course, I always want to thank our VIPs. Patty, you guys, thanks for always going VIP. Much appreciated. VIP means you get a pizza and a couple drinks, and you always get to sit in the front row. You have something you want to say? Oh, 312-543-7555. I'm not really good to call. Just shoot me a text. By text, I'm great. Sound good? But you guys can hang out here and, network a little bit and go see the bartenders over there. And if not, go downstairs and have a nice dinner at Adamo. Thanks again, you guys. Have a great night. We'll turn some music on. Thank you.